Ladies and gentlemen, welcome to OO versus FP. Woohoo! Shortened to OOPS. These are our panelists. Apparently, no one seems to be very organized in terms of knowing who's what. I was tapped to be the moderator, like, I don't know, a couple of hours ago. So this is going to be fun. We're obviously a very FP-heavy crowd, but I would invite you to kind of keep an open mind and/or ask hostile questions about OO. Please ask questions, come up with stuff, heckle me, heckle the panel, and we're gonna have some fun. And if we've got some prepared questions, they can just say stuff, whatever it is, but we're gonna try to keep it kind of flowing and loose and fill up an hour with something that will hopefully be entertaining and enlightening. So, all right. I'm going to ask each of the three panelists to take 3 sentences, introduce yourself, and give us your favorite functional programming metaphor and your favorite object-oriented programming metaphor. Metaphor for the paradigm. Luis, you get to go first.
Okay, so my favorite object-oriented metaphor, I'll try with the harder one. This one.
You want to identify yourself?
I'm Alex Kochar. I'm a software engineer working in Lausanne, and I'm contributing an open source project on Haskell and Scala. Mainly contributor of Scala Z. I would say if I would take something from object-oriented programming, from my experience in Scala, it would be what I can do with modules. Basically, how I can use companion objects and things like that to abstract modules away, something I cannot do in Haskell. From the functional side, I will take everything, I don't know, lenses, because maybe that's something I don't see any way you could do something like that in object-oriented programming.
Hello, I'm Ryan DeLucchi, and I work at Verizon AOL, and I would say 2 metaphors I would like to apply for. I see OOP sort of as a blunt instrument, so anything that would be a good blunt instrument, I guess, would follow as a good metaphor. Maybe like
Class hammer.
A really hard sledgehammer that sort of falls apart as you want. Anyway, FP would be, I think this more generally, I like to think of it as like Legos, just simple small pieces I can assemble and build. You'll build basically, whatever you want. You may have to use a lot of Legos, but you can build anything. So that's.
I'm Chris Allen, and I was going to take anything from object-oriented programming. I think Ellie's kind of stole my favorite, probably ML module style encapsulation. But if we're going to give that one up, I'd say Alan Kay's idea of everything is an object. I don't actually want objects, I actually want everything to be a lambda. But the monism and the simplicity that you're trying to reach for, I think, can actually bring some really unexpected benefits in a programming language. And then in functional programming languages, I read about Haskell, and there's not much of a cross out.
All right, awesome. So again, if you have any questions at any time or you just want to say something to the panelists, do we have someone in the back there?
Yeah. What do you think about the third dimension, non-determinism?
The question was, what do you think about the third dimension, non-determinism? So I'm going to ask one of the panelists, please take point, and then the others rebut, and then we'll move on. Non-determinism? Anyone?
All I'll say about non-determinism is that when Alan Kay was kind of defining and inventing object-oriented programming, and he was designing Smalltalk, he was borrowing from Simula, which had an actor model on the site. Used the actor model and had this idea of independent processes, right? And the closest thing you're going to find to that today is Erlang. Notably, though, one of the things he dropped from Simula when he designed Smalltalk was the asynchrony. So he actually mostly just wanted kind of the model of objects talking to each other, the message passing, like an actor model, but he actually dropped non-determinism. So I think that's something that maybe couldn't be considered native, though.
Yes, it feels like, generally speaking, we might want to use some dirty things with OP, but maybe that's just because today we're not able to find a better solution, and that's how I kind of relate to that.
Yeah. No, I would say that non-determinism. It's a difficult thing to model. Either with either approach. Some of the tools that I see, you see like Scala Z Stream, You'll notice the non-determinism package, is a really good approach for that. So
Okay, so we have a pre-prepared submitted question, and that deals with the title of this panel, which is OO versus FP. Here's the question: is it really versus? Are these two really actually in conflict, or is there some synthesis between the two that makes any sense?
So, yeah, I mean, I don't know if for those of you who've seen this morning a talk from Stefan Kompal about variance, and I think it's really straight to the point about this, is that what does OOP really bring to the table that you couldn't do without it, right? And there was really a clear explanation that basically if you have contravariance in your system, you can basically emulate any of these things that subtyping is doing. So then it may be more handy, but yeah, I'm not sure.
Yeah. For me, I came to FP seeing FP as like sort of an extension of OOP, where inheritance, encapsulation, polymorphism, these seem like great ideas. And I've noticed, like, over time, a lot of the patterns and approaches in OOP that I've used to solve problems, I find myself replacing them with using, an FP concept that seems to fit more closely match the problem I'm trying to solve. So it was never about, okay, now I'm going to drop OOP and just do everything in the FP approach. No, it was more organic, and that actually just tended to happen as I'm solving more complex problems. So when I say when I think OOP versus FP, I think organically you just sort of progress towards using FP to solve the problems.
I tend to kind of decompose it in my mind. I mean, I see programming languages as kind of a bag of features that either hang together pretty well or don't, and some features need other features to really work well. I mean, certainly you can't currying without lambdas, right? And some features you can just kind of pick or choose, right? Like some features you can just kind of add to programming languages that might be more on the FP side or on the OOP side. So I don't see it as a versus, but I'm also in a situation where a lot of the problems that OOP language design will try to solve end up just not being problems. I mean, for example, we have encapsulation in Haskell. It's not as good as ML modules, but you can't do an abstract data type. But we often don't bother because our data is all immutable anyway. So it just becomes less compelling or less necessary to go to that trouble to begin with, or say like dependency injection and reader, things like that. So I'm mostly kind of keeping like a PL feature checklist in my head of like, okay, to do my work, I need A, B, Z, so on and so forth.
Cool. We're going to go left to right. Vincent?
Given that we talked about variance and having functions that can be go to different variants, what does subtyping get us that we could not get in?
So the question, if I can distill it, is given that we've talked about things like abstracting over variance, what does subtyping get us that we can't get already in native FP? Anyone? For the audio, Eloise just shrugged very conspicuously.
There's some.
Use mic.
Yeah, there was I forget exactly what the sticking point was, but Miles Sabin recently was trying to encode a red-black tree implementation using in the type system, and he ran into a few issues with representing certain cases. Maybe somebody here might remember this, but there was like a certain point where he actually had to define a subtype, using inheritance, but it was only for like a small piece of the problem. So there are cases there, but I would say it's mostly an artifact of the Scala language, more than about FP per se.
I'm just going to attack the premise of the subtyping is necessarily an OOP thing. If anybody here has ever used OCaml, they actually have some limited applications of subtyping that are pretty nice. If you've ever row type polymorphism or anything like that. I certainly don't think you should unleash subtyping in general in the entire language, as part of your kind of general, the way your data types work in it, because A, it's not necessary, B, break inference, but it's, certainly FP languages can make use of it. It's just what is it getting for you? Because I think in a lot of cases, you feel like in an OOP language you need subtyping because they don't have all the other things that FP languages use to accomplish without it.
Yeah, if we look concretely what we can do, you can find some implementation in a Pascal of HList, an even more sophisticated system where you can basically replicate what you do with subtyping in a OOP language. So I don't see any future you could do.
Okay, there's a question over here. Yeah, you.
So I think I'm kind of different than most people here. I came to this conference instead of another one. And so I've been like 20 years in pretty disciplined OO. But from a higher perspective, like I don't have a CS degree and I suck at math. But the stuff was blowing my mind, even though I thought I was a good programmer. So one benefit, I think, is OO is much more accessible than all of these things that you're talking about. They look like Greek to me, even though I've been programming for 25 years and from mainframes to pretty modern OO.
Okay, so to repeat the statement, which I think is a really interesting talking point. It's discussing how one benefit of OO is that it's more accessible than FP, especially for developers who've been around for a long time. I imagine you guys are going to jump on this.
Yeah, so actually I think it's based on prior experience more than anything else. And the first time because I come from OOP as well, and the first time someone told me, oh look, you can model this, there is a vegetable and then you can make a carrot, or there was the example with an animal and a dog. But it was saying, that way you model your object like in the real life. It never felt to me like it was like the real life. Because then it pushed me constrained that I was not able to encode, and it was not really reflecting what I had in my mind. Something else is I see when I get new people in my team, which are not really experienced in programming in general. Getting all these functional concepts is probably easier for them because they don't have all this baggage before.
Yeah, I agree that initially OOP can be more accessible, and I remember when I first started OOP, I was excited about it. I thought, hey, this is a really cool way to, to model your code. But then when I started applying it to problems, of not even high complexity, even like say moderate complexity, I've actually noticed. I've always found it a very frustrating experience trying to say, okay, how am I using inheritance here? Should I use composition here? There's a lot of arbitrary decisions where, like, you say, okay, this is private, this is protected, this is public. Okay, who decided that? How does that? It's completely arbitrary. I mean, and usually end up changing it later. You have somebody go, oh no, that should be protected, and you start having these arguments, or people start fighting. Oh no, it should be private. And in reality, when you look at FP, for example, you might have like a natural transformation where the type is actually abstracted away, and there you go. You have you're abstracting over a type, and the type actually doesn't really matter. So you talk of natural transform from N of A to M of A. So A doesn't matter. So that right there it's just defined by the laws of a natural transformation. It's not arbitrary anymore.
I'm going to take a slightly different angle, and instead of talking about code, I'll just make a note about like human languages. I mean, saying like OOP languages are simpler, easier to learn, or easier to train people on is like an English speaker saying English is easier to learn than Chinese. I mean, that's just what you started with, that's what you know, that's what you're comfortable with. I mean, I've worked with people who've never programmed before, and now their only language is Haskell, and they find everything that working programmers use entirely baffling. They think working programmers are actually insane. So, it's entirely based on your experiences, and certainly somebody that's working within a familiar set of languages is going to have an easier time changing languages. I don't deny that. But we maybe want to, kind of escape the local maxima we've grown comfortable with.
I'm sorry, I don't think you're all insane. Not very
I do.
Okay, we're going to do another question. Yeah, we're going to come back to the left here.
I actually just wanted to add that I've also been programming for 25 years, suck at math, and did object-oriented for about 10, and then switched to FB. And just as an anecdotal example, there was a little toy idea I had that I wanted to find the right answer for, so I didn't really want to solve it. I didn't want to, finish it. I wanted to solve it. And I spent 6 years occasionally coming back to it and, spending all night going, I'm giving up. And then I learned a little bit of functional programming, and I That's topological,
So
there were problems, like I had this diamond problem where it was like a flow thing where I had to send up a lock and unlock and all of that went away.
So to summarize, then FP is awesome. In the front row here.
The problem I see is that when you say FP versus OOP, you're not defining your terms. Back in the 80s, 90s, FP basically meant something that has parametric polymorphism, and OOP basically meant something that has ad hoc polymorphism. Now, every language has both. C++ has adopted templates, so parametric polymorphism, and Haskell has type classes, so ad hoc polymorphism. So these features do not distinguish languages anymore.
So the reason Daniel's handing me the mic is I actually read Alan Kay's his diaspora of words on the internet, including the one Stack Overflow answer he's ever written, and he defined the term. So I'm going to let him, take credit for that. And I mean the emphasis. Yeah, I know I've got it right here. I'm cheating. But I will say that the emphasis on parametric polymorphism and other things that happened later after OOP kind of already been defined by Alan Kay is an artifact of the fact that C++ and other popular OOP languages borrowed from a different language family called modula. That wasn't really what Alan Kay had in mind. It's a perfectly valid choice. I mean, certainly I'm in favor of more types, right? But the original, definition was essentially actor models stripped of the asynchrony, stripped of any real non-deterministic concurrency, immutable messages pass between objects, everything's an object, top to bottom, even numbers, kind of like Ruby, right? And that's about it. I mean, I could go into more detail and list more things, but that's really just the definition. That actually doesn't give us a lot to work with. So at that point, I think you have to take a descriptive disposition and just accept that people have redefined it.
That's ad hoc polymorphism. That's all that is.
Yeah.
So I think yes, you can do both polymorphism in any of the approach, but then it comes down to how you deal with variance, and I think that's really the variance in your type system. I mean, I'm talking about statically typed language, and I think that really make a massive difference. But by giving all these different directions where you can, get your function kind of inferred, it makes things much more complex to reason about, and I think that's. I mean, there's different. In my opinion, it make things more complex. But even if it's in both approach, you can use both approach to polymorphism. There's still this fundamental difference about the variance.
Very quickly.
Real quickly about ad hoc polymorphism, Alan Kay would say you don't actually need types or ad hoc polymorphism because what he wants is super, super late binding so that you can just case on the types and get ad hoc behavior that way. I am not endorsing that. I am simply the mouth of Sauron.
You're going to be our first. All right, we need one more really quick question. Yes.
Is it really fair to talk about the theoretical origins or Alan Kay wanted from OO? And most people think their connotation of OO is just like a reflective, mutable language like Java, C++, possibly even Ruby. That's what people think when they think OO, right? So does it really matter? Or what do you think about that?
So the question for the recording is, when you say OO, people think of sucky languages like Java and Ruby. Is it even fair to talk about Alan Kay anymore when these impure monstrosities are wandering around? Very quickly.
I think it's fair to say that when you say OOP versus FP, there's a lot of connotations come with that actually go beyond the language itself. You look at the ecosystems. You look at Spring and different tools that mountains of XML configuration, things like that. And I think, that does sort of weaken the clarity on the difference between two. But the reality is we understand that these are an ecosystem, the ecosystem of OOP developers and the ecosystem of FP developers. They kind of follow, they have their ecosystem, they have their certain types of tools, and they follow certain patterns in how they build things. So is everybody else?
All right, so we're going to close with one final question here. And I'm gonna be selfish and ask it. I'm sorry. Now, all of our panelists are on Twitter, which is this wonderful place where you can yell at people and sort of not have to acknowledge when you're wrong. It's great. I love this platform. So yeah, so send them things on Twitter, and then we can all see it and like acknowledge it. I have a question for each of you. 30 seconds apiece, please. If, let's say, someone locked you in a room by yourself and forced you to write Java for your food, how would you structure your code to keep yourself sane?
I'd punish them by making tricky use of static initializer behavior for their JLS, so they couldn't understand anything I wrote or maintain it or modify it.
I would just go to town with anonymous interclasses. I would not use inheritance at all. Yeah, from there pretty much. Yeah.
Why are you trying to be constructive?
Yeah, well, I would basically do the same thing, but then there's a bunch of libraries that help you to survive in the Java land. There's a function on the Java libraries. There's someone created a sort of source code generator which allow you to create a jailbreak data type, so you can survive, but it would be hard.
All right, this has been really fun. I'm sorry we have to end here, but like I said, Twitter is great, Slack channel is great. Twitter is better because then you can scream into a voice. Thank you so much for our panelists.